This is a video made for Social Work 110 at Sacramento State University. This is week 13, and this is a video that is covering the practice problems on participation sheet for week 13. I'm going to go right into it, and the first problem reads, a social worker would like to compare the average rates of nights spent without shelter per year for homeless individuals in Sacramento and the average rate for the state of California. Based on this information, what seems to be the most appropriate kind of research? Your choices are one sample t-test, two sample independent t-test, two sample dependent t-test, and correlation coefficient. In this particular case, the correct answer is A, one sample t-test. And the reason I know this is from the language. First of all, I know it's a t-test because it's comparing the average rates. And we are comparing the average rates of individuals. We're talking about nights spent without shelter in Sacramento versus the average rate for the state of California. And since Sacramento would be a sample from California, we're talking about a sample from Sacramento from the state of California. So here's your population and here's your sample. So anytime you're taking a sample from a greater population and comparing the averages of both to each other, you are participating in a one sample t-test. Next, number two, a researcher wants to compare the average number of days receiving emergency room services between a group of Caucasian individuals and a group of African American individuals. In making this comparison, which statistical analysis is most appropriate? And again, you have the same choices. In this particular case, we're going to take B, two sample independent t-test, and the reason why is because we have the average, which is again going to signify t-test. And we're talking about the average number between a group of Caucasians and a group of African American individuals. So we're having samples from both Caucasian and African American individuals. And in this particular case, we're talking about ethnic groups being distinct or different. We're taking samples from each one. So we have two different populations and samples from each being compared. That's going to give us an indication that we're using a two sample independent t-test. Next. Number three, a social worker wants to know if a relationship exists between weeks spent in music therapy, in a music therapy group, and the level of anxiety felt by participants on a scale of 0 to 10, where 0 is no anxiety and 10 is the highest anxiety. Here, which statistical analysis works best? In this particular case, we're going to be talking about D, correlation coefficient. And how do I know this? Well, we're not looking for averages, we're looking for a relationship, and it's between two variables, weeks and level of anxiety. So you can also tell that this is a t-test. We're looking at pairings of we're looking at pairings of these measurements of weeks and level of anxiety with individuals. You can kind of imagine that being, again, set up with an individual and the number of weeks as being one variable and then the level of anxiety being the other variable. Gives you a pretty clear picture of a correlation coefficient. Number four, social worker is interested in examining whether a statistical difference exists between the average level of depressed individuals in a mindfulness-based group and a similar group in an exercise-based class. Which statistical analysis seems to fit best in this scenario? Now, the answer is C, two sample dependent t-test, and the reason why? We know it's a t-test. We see that we are again interested in average, but also I threw in here another clue, which is statistical difference. So statistical difference instead of correlation or association or relationship. That's another way to kind of remember that. And then again, we're looking at level of depressed individuals, and that's true for both the mindfulness group and for the exercise-based group. So the depressed individuals is going to comprise the population from which we're selecting both samples. So the mindfulness-based group has a sample of depressed individuals, and so does the exercise-based group. So they're both coming from the same population, and that's why the two-sample dependent t-test is correct. Okay, now we're going to go ahead and move on to the problem, which is a correlation coefficient problem, which is also listed on the participation sheet for this week. Now we're going to start with the fact pattern for the correlation coefficient, and I'm going to walk you through the steps. If you haven't already, please make sure that you've hopefully already done this. I think it's going to be a better learning exercise for you if you do the problem first, and then you're able to correct it with my video. That way, again, you're kind of correcting your own work rather than just following along with what I'm doing, which probably won't help you as much. But nonetheless, if you need to, go ahead and pause and do that now. But if you already have, we'll go ahead and read the fact pattern. A social worker wants to examine whether a relationship exists between the number of times a youth is suspended from a school and level of anxiety. To test this, she interviews a random sample of 10 students from local high schools and asks about the number of times each has been suspended in the past year and the level of anxiety on a scale of 0 to 10, where 0 represents no anxiety and 10 represents the highest level of anxiety. And you can imagine, again, why this is a correlation coefficient problem. We're talking about a relationship, not an average. A relationship, not an average. Okay, that's one thing. And the other thing is we have two variables here. The first is the number of times suspended, and the second is level of anxiety. So you can kind of in your mind get a picture of what this looks like, but in case you didn't have a picture of it, or if you're having kind of a hard time getting the picture, I went ahead and gave you a actual graph. Okay, and you have individual 1, 2, 3, all the way to 10. And then for individual 1, we have suspended 5 times. Anxiety levels at a 9, so pretty high. Okay, individual 2 is suspended once, and anxiety level at about a 2, so again, pretty low. You can kind of see how this plays out, so we go ahead and have a figure here for that, and I'm sure you already had a chance to glance over that on the participation sheet. Then the next question becomes, how do we go ahead and use these data points to begin an analysis to ultimately end up with a Pearson's R correlation coefficient? And as usual, the way I do it is I create a chart. And the chart has the x squared y squared xy. So again, we have the x variable, the x squared variable, the y squared, and the xy. And the way I set this up is I put all of the x's in their own column, the x values, and then the y values, which are corresponding. So you'll notice on the previous chart, the 5 and the 9, there's the 5 and there's the 9, the 1 and the 2. Let's see if I got that right. 1 and 2, yep. So you can see how they all kind of line up. I made them vertical instead of horizontal, but the reason I do this is so that students recognize that what we're multiplying together first is the x and the y to form the product column. So of course we go across 5 times 9, and we end up right here with 40. 1 times 2, we end up in the xy column with 2. Okay, 4 times 5, 20, and so on and so forth. And then once you do that, we'll go ahead and bring it to the next slide, and we have all of those answers. So you can see what I did here. Okay, in the x column for the first individual, 5. Okay, and the corresponding value for the y variable is 9. So 5 times 9, 45, and then we went on just like I did before, all the way down to 1 times 3 equals 3. So again, that's what this column looks like. Okay. And then I think you already know, because we have these blank columns here left over, but they're easier on your eyes if you're able to just take them one at a time. So again, we're going to start with the x squared column, and then we'll go over to the y squared column. So on the next slide, we'll start with those. Okay, so for the x squared, let's see if I get this right. 5 times itself is 25, 1 times itself is 1, 4 times itself is 16, 6 times itself is 36, 7 times 7 is 49, 3 squared is 9, 8 times 8 is 64, 4 times itself is 16, 2 times 2 is 4, 1 times 1 is 1. Okay, we'll go over to the y squared column, which I've also completed for you here. 9 times 9 is 81, 2 times 2 is 4, 5 times 5 is 25, same. Okay. Then we have 6 times 6, 36, 7 times 7, 49. Okay, 10 times 10 is 100, 8 times 8, 64, 4 times 4, 16, 3 times 3 is 9. So really, we didn't have to spend a whole lot of time getting those down. It's just a matter of multiplication, and they're all pretty basic. You didn't have to go too far down the multiplication table to reach for any of these. But then the last section is we're going to be able to get the sums, and they're represented by the sigmas in the bottom row here. And so I'll go ahead and show you what I did, and hopefully you've already done that, and what you're doing now is just checking your answers. Okay, so here's what I did when I added 5 plus 1 plus 4 plus 6 all the way down. I got a total of 41. Okay, And for the x squared column, I have a sum of x squared of 221. Y column, sum of y is 59. For the y squared column, we have a sum of y squared is 409. Okay, and finally, the product of x and y column, we have a sigma xy of 283. So now that we have all of the values we need to work with, we can move on to doing the calculation portion and get the calculated Pearson's R value. So for this section, I've gone ahead and I have entered in all of our data points, or all of our sums rather, on the left-hand side in the text box, and I've written out the formula for the Pearson's R correlation coefficient on the right-hand side in the drawing box, and you can see I have the formula here with the n, sum of xy, sum of x, sum of y. Okay, you see the sum of x squared and the sum of x squared, the sum of y squared and the sum of y squared. Now, how do they do this? You already remember that there are 10 pairs in the fact pattern. There are 10 individuals. There's 10 pairs of scores. Each individual has a score for the variable of number of times suspended, and the other variable is, of course, the anxiety level. So with respect to the sums, I plugged them in as such. We have the n value at 10 right here. So for everywhere I saw an n, right there, there's 3 of them. I put the 10, 1, 2, 3, there's 10. Okay, and then for the the sum of xy, which is the product of xy, you can see from our tabulations, 283, I plugged it in there. Okay, and then we see the sum of x is 41, so I put that there. Sum of y, I plug that in at 59 right there. Okay, and then of course when I found for the equation sum of x squared, well, okay, sum of x squared is right there, so I put the 221 there. And then sum of x, remember these two are the same right there. So the 41 just drops down into this particular this particular variable, this placeholder as I like to call them, jumped over the fence. Okay, and then we see on the y box, the n is 10, and then the sum of y squared. Sum of y squared is 409. I put that in there. And then the sum of y squared, okay, the sum of y squared rather, okay, sum of y is right there. It's the same value as there. So for this one, when I plugged in the variables, 59 goes up here. So we already saw that up here. Here's the sum of y is 59. Okay, sum of y is 59. And then we have the sum of y, okay, 59 right there. So on the next section, I'm going to go ahead and do the calculations, and you can follow along. So now we're going to go ahead and go through the calculations. I hope you've already done yours so you can follow along with me, and it's not so much a matter of you getting my answer, it's that you're checking your own. So if we left off right here with this application of all of the facts we found so far, all of the sums we found so far applied to the equation, when we start to calculate them, you can see how they came out. If we're looking at the numerator, 283 times 10 is just going to be 283 with a 0 at the end, so 2,830. 41 times 59, a little trickier. You must use a calculator usually for that one, 2419. Okay, now we'll go up here. We have 221 times 10. You know how to do that. We have 2,210 right there. And we have that 41 that dropped here. Okay, 41 squared is going to be 1,681. Let's go over to the y box now. 409 times 10, 4,090. 59, because you dropped the 59 there. Okay, 59 squared, 3,481. So now we have this particular, this iteration of our equation done. And when we start to crunch the numbers a little bit further, we subtract 2,419 from 2,830, and we get 411. And when we subtract 1681 from 2210, we get 529. Take away 3,481 from 4,090, and you get 609. So we have some really manageable numbers we're working out with by now. So we move over the numerator of 411, and when you multiply 529 times 609, you're going to get 322,161. Take the square root of that, and you get 567.59. Now, you can see that this is, of course, going to be a decimal because in order for it to be a 1, we'd have to have the numerator and the denominator to be exactly the same, and clearly we don't have that here. For 11 is, of course, lower than 567.59, and when we divide 411 by 569.59, we're going to get 0.72, which is, if you can imagine, I'll go ahead and draw that up here for you real quick. If you can go ahead and imagine what this must look like. First of all, because it is, in fact, a positive number, we know that we're going to be working with a positive correlation going up this way. So it's going to be, as the x is getting bigger, so is the y value. Okay, so we start with a low x, we have a low y. Then as we begin to get bigger x values, we're going to get bigger y values as well. Okay, so it's probably going to, and it's not a perfect 0.72 is probably going to be a little bit thicker than, it's a little bit more spread out than what we've been seeing in the past with the 0.8s and the 0.9s, so it's a little thicker. I'm not doing the best job here making it look like data points, but you get the idea, I think, how this probably looks. Okay, so 0.72 looks something like this. Okay, not a perfect straight line, but a little wider. I mean, you still really get the idea. So as the x value is rising, so is the y value. So we're tending to see translated to our fact pattern, or rather applied to our fact pattern, the more suspensions a child has or a teenager has, the more likely their anxiety is to be higher. Okay, so that's how you kind of read that. So now what we'll do is we'll continue along with the fact pattern and see what we find in terms of degrees of freedom and critical value. Okay, getting a little bit further along here, we have the critical value for R, 0.72. Now we need to find the critical value. So, I'm sorry, the R calculated is 0.72. We need to find the critical value, and the way we do that is we have to begin with the degrees of freedom. The problem for the degrees of freedom is n minus 2. For our fact pattern, we have 10 pairs, and if we subtract 2 from 10, we get 8. And our chart on page 81 has us put our finger on the DF, move down to an 8. We move across to the 0.05. We're going to get a value, and that value is going to be 0.632. Okay, 0.632. And double checking that, we have it correct. And I'm going to go ahead and just highlight that thread to make it look a little more easy on the eye. There we go. So now we have one last thing left to do, actually maybe two. We have a calculated value of 0.72. We have a critical value of 0.632. We know that the 0.72 is stronger than the 0.632. So we are going to, in this particular case, reject the null. We'll just say reject the null. There you go. Okay, so if you reject the null, and I didn't have you write it on this sheet. I just went through the calculations on this video, but I know that I asked you a series of questions following the fact pattern, but if we go back to it and just think about it for a moment, well, the null hypothesis for correlation reads there is no relationship between, in this particular case, number of suspensions for teenagers and level of anxiety. Okay, so if we're rejecting the null hypothesis, we're rejecting that sentence. We're rejecting the sentence that says there is no relationship between number of suspensions and level of anxiety for the teenagers. So in effect, we found that there was a correlation, or there is a correlation between number of suspensions and anxiety. And the last question I asked you is about the p-value. What do we say about this p-value? Well, we know that there's two ways to look at a null hypothesis. If you look at it from the calculated and critical value, you're comparing these two. If you're looking at it from a p-value perspective, We're going to say that we reject the null when the p-value is less than or equal to 0.05. Okay, we're going to say that we accept the null hypothesis when the value of the p is greater than 0.05, and because we already rejected the null in this case, we're going to say that the p-value is less than or equal to 0.05. And I'm pretty sure that concludes our work for today with respect to the 4 questions I had you started out with, the practice problems about how to read the fact patterns, noticing what the key terms are that allow you to find the right answer. And we went through all of the calculations for the correlation problem I gave you. And we answered the questions that followed it, A through F, or I think it's actually A through E, on your sheet. Hopefully that was helpful to you. Thanks for doing this, and I'm glad that you're watching this video now, and I'm hoping it was useful. Thanks so much.